You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 93. Hey everyone, this is Freddie Guime. I am one of the co-hosts here at Java Pop House, principal engineer at Expedia, speaker, author, and I'm here with my comrade in arms, Bob.
Hi everybody, Bob Paulin, independent consultant from Chicago, Apache Software Foundation member, Java champion, speaker, and CJUG board chair.
Yeah. So this episode is essentially part 2 of our sort of like not your grandpa serialization frameworks, right? And it's super fun because we're going to cover now some of the more modern sort of serialization techniques. Like we said, if you're still using object output stream and object input stream, probably, if it's a new project, probably it's a good idea to start consider some other alternatives.
And I thought we already considered the grandpa's version in the last episode, right? So we did Jackson, which has been around for a very long time, and then JaxB.
Which is actually even older than Jackson.
Much older, yeah. So getting back into SOAP and XML land. So
yeah. Before we start, I wanted to first thank our sponsors, Datadog. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 400 technologies, including AWS services like Docker and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place, so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. Again, javapophouse.com/Datadog. So give them a try. You get a free t-shirt, and we used the products before, and they're incredible. So give them a shot. All right. So I guess the the Adam and Eve of serialization will be object output stream and object input stream and serializable and all that. People really should not use that anymore if you have a choice. And we sort of covered at the very beginning, which was, like you said, XML and JaxB, and then Jackson, which is sort of like the less verbose version.
Yep. So now, and now we're moving into the more kind of modern and, does it all for you type of frameworky stuff, right? So now we're getting into, where you're rolling your own quite a bit, really when you're talking about JaxB and you're talking about Jackson, you're really just talking about how the format you're sending the file over the network, right? Mm-hmm. So, there's more to it than that when you're trying to transmit data. So what if I want something to do all that for me rather than having to build all the network stack and everything around it myself?
Yeah, right. Something that does a binary compatibility. And to be honest, the other part is that what a lot of this and it's interesting because you can sort of see it like on when you're talking to different developers, you can tell the era of the developer. Like there will be developers that's like, why is everything on text? And these are like the folks that grew up on the 80s or 70s or maybe 90s where networking and space was a big concern. And you have this sort of like binary payloads that were very, very succinct, that were sort of like encoded efficiently. And then suddenly after the 90s, when you start hitting the 90s, 2000s, suddenly space was less of a concern. People are like, it was more important for them to be able to view this stuff, to be able to troubleshoot things. So, we get this sort of like this very verbose XML protocol that is essentially a text protocol. Right, and then we actually see Json as well, which is another text protocol, a little bit more succinct, but it's still text. and you can see like all this sort of like call it old timers because we'll be old timers. Like remember like with fondness. It's like, wow, I remember when binary was a thing.
Well, I mean, honestly, age is a state of mind, and I think one of the things we're going to see as we go into how a lot of these frameworks, maybe not as much gRPC, but Thrift, when we talk about that, what's old is new again. I mean, I do also remember the days of when you had to declare the field length. How long is your string going to be because it can't be any longer, and that was you're aligning to the machines. There was a place in the tables in that DB2 database that only was sized for a certain amount because you had limited space, and really, why not enforce that constraint? When you're sending the data over the network. So there is cases for actually having those constraints, just as far as even speed off the network when speed is in fact critical. But as things have changed, as it's really been more about the developer cycles and how quickly you can debug all of these messages going over the network, we have seen kind of a trend going more towards the human readable messages since, do I really need a few extra milliseconds? Maybe not in some contexts.
Yeah. Right. So let's go over and sort of like describe, because I want to go into what Protobufs is and why is it something that the old guard gets excited about, and the new guard is actually happy about it, even though confused, like why would we want to use that? And and what Protobufs is let me share my screen so people can see. Ooh. I think you need to enable sharing screen.
Let me do that. I can do multiple, can share at one time. But how can I allow you to share? I can share my screen.
Now I think I can share now. Let's see.
All right, there you go. Yep, I can see it. Oh, it's clear as day. Let's go.
All right.
I'm going to crack open my beverage then.
Yes. Oh, I already have mine. I'm already working on that.
All right, cheers.
Cheers. So what Protobufs is essentially it's a way to declare a binary format message. Right, and the idea is that in itself is not that big of a deal, but the way that the Protobuf protocol is done is very efficient on the wire, and that means that it is very succinct, is very compact. On top of that, what Protobufs is, it gives you essentially a way for you to interact with your favorite language, as long as your favorite language happens to be Java, Python, C++, .NET. Like they have like 6 or 7, and essentially what Google did, because Protobufs is essentially a Google creation. What they did is essentially they created this sort of like almost like an XSD, which is a descriptor language of what a Protobuf should look like. So let's see, for example, real quick so people can see it. So this is a Protobuf. We call it a data model.proto. And essentially here we describe what the message would look like, right? So there's an order proto, which, it has an order will have a customer and it have a bunch of items, right? And, you have customer proto, which then you define as having a string of a name, a string of an address, and a string of a phone. Yep. You also have, the items, which is like, sort of like an int32 for the item ID, a string name, and a string price. And what we do is that with this sort of like template and definition, then sort of like the Protobuf, what they call it, like the Protobuf compilers, can take this text file, which is the definitions, and produce you Java files that that represent these particular structures. So in this particular case, I'm just going to go straight out to how the generated file looks like, so you can take a little bit of a flavor on how that look like.
Yep, and really this is going to sound familiar in both frameworks we're going to talk about tonight. Is what we're really doing is this is kind of contract first development, right? So where you're developing the data contracts between the services that are going to talk to each other, you can agree on that. It's in a language agnostic format where I can bring it into Python, I can bring it into Java, I can go into C++, any language that the framework supports, and we have agreed on what the format looks like, so we can talk to one another.
Yeah, no, this is actually a very good way for doing like not necessarily just inter-process communication, but essentially in inter-service communication, where another service might be written in a completely different language. But as long as they have the same proto contract, they can generate something on their language that they can read, and it becomes super easy for them to actually interact with it.
Yep.
So what you can see is, for example, that it generated all this code for me. It generated order proto, and order proto will have essentially a bunch of methods that allows it to for example, there will be builders that allows you to build, and there will be like the items and customer are part in there too. So we actually have, for example, we have the actual customer proto, and essentially all these helper methods for you to actually create. The way that this will look like if I were to build things will be essentially, let's just go here and then for data model test. It's actually kind of fun because it uses the concept of builders, right? So if you haven't seen builders, what builders are a specific type of pattern, some kind call it the train wreck pattern, because everything looks like a little train. But the idea is that you essentially create a builder and then you set the properties. And when you set the properties, the return value of each of the set methods is the same builder itself. What that allows you to do is doing things like, for example, here I'm setting the customer, and then I'm clicking in, for example, add items, because there's a way for me to add multiple items instead of just setting one item, because it's a repeated field. And then I just can, for example, here when I'm setting the customer, I can declare, that I want a customer proto, a new builder, and then I'm in that customer proto setting the name, setting the address, setting the phone, and when I'm done setting all these fields, I just call the build method. The advantage of the builder pattern is that it allows you to essentially compose how your object is finally created. A lot of the things that happens is it sort of achieves a lot of one of the things that we love, and we always encourage is like if you can have immutable objects. The reason why we encourage immutable objects is because they are one of the most thread-safe objects that you can create. Usually an immutable object you can share across threads because the visibility is there, because everything was set up at creation. So it also allows you to have sort of like this, I don't have to have everything to actually create my object. For example, if you have an immutable object, usually what will happen is you have to specify everything in the constructor. And when you specify everything in the constructor, sometimes you say like, oh, I need this to be null, or it needs to be 0, or I need this to be empty because I don't need it for this object. And that makes a lot of like calling like a new customer, with all these null fields or 0 fields, kind of like cumbersome. It looks very weird when you're actually looking at the code, and you don't necessarily can match what we're just setting in there. So here, then it becomes very specific. Oh, I'm setting the name to Freddie Gimme. I'm setting my address to 123 Cool Avenue. I'm setting my phone. So it is visually more appealing and much easier to read. Less chances to make a mistake if somebody changes your constructor, or if you're adding a new field and you have to find out if that was a field you wanted to have null. I don't know if you ever have that experience. That's always a little bit hairy, right?
Yep. And the way this works is each one of these set methods returns the builder. So, I mean, you can call any of these methods in any order that you want, and you're still going to get the same object back. And at the end, you call the build method, which is on any of the builders, and you get the actual object.
Yes.
So it's kind of like you've got a factory pattern inside of this builder where you're just generating new objects each time you call it build.
Mm-hmm. And so the fun part is once we do it this way, right? Like we have a set customer and items, what the Protos will do is it will give you sort of like this method, which is to byte array. And what that is essentially a binary representation of the particular object you have. And this binary representation is what you can, either send down the wire, write into a file, read to a file, be what you wanted it to be, but is very efficient. As a sort of like a preamble, let's do the order type test, right? One of the things that we do here is we print the size of how big this, essentially, it prints the size of how big our XML generation takes, right? And we're going to do this. We did this in the last episode. We're going to do it again just so you can see how much of the space it takes. For this particular object, right, where we have, an item type, a special JOYO, and, we create an order, our XML equivalent was around 350 bytes. So, it's a small object, and for this particular order is not a lot of bytes, right?
But for the amount of data that's there.
Yeah, right.
It's more ceremony than data.
Yeah. If you think about it, we're probably spending more time. Yeah, like Bob is right. We're spending more bytes describing what the data would be than the actual data itself. Now, when we actually go to our proto example, right? We almost have exactly the same example, same fields, same sort of like information. And when we run it, you can see that, the size of our proto, and this is before compression, if you happen to have something like gzip or stuff like that, it's 71 bytes. So, that is almost like, not quite, but almost like an order of magnitude, half an order of magnitude than what it was on the actual XML.
Now, are you cheating a little bit? Because you did convert it to hex, which is going to compress it a little bit from a binary protocol, right?
No, actually, it's the other way around. Well, so I'm printing this out because this is essentially an X string. So 0A, 2A, or 0, A2, A0, A0, right? But
okay, so it is. I mean, if you were going to do it in like ASCII or something, this is longer, is what you're saying.
Yeah, this is actually
you're going to
longer.
do characters. Yeah. Yep, got it.
Yeah. So the idea is that, again, this is not significant on this particular example in the sense that 70 bytes versus 300 bytes, who cares, right? But if you think about it, of the amount of if you look at a server and see its network card, and you imagine that that could be like, if that is your bottleneck, right? Like you're looking at your server, you're pushing as many bytes, you have a gigabit, network card, and that is maxed out. You are IO bound because you're sending and receiving all this information. If you happen to switch from XML to Protobufs, just on that particular change, suddenly you have, 5 times more room to actually do more stuff. And that means a reduction of, let's say that you have 100 servers, then that means that you only need 25 servers. And like if you need budget for a promotion or budget for
yeah, as long as you're not CPU bound or memory bound, if you're network bound, this is a gold mine.
Yes.
And yeah, the apples to apples comparison would be if you would have taken that XML and turned it into a byte array as well. And then we could see the absolute difference.
The absolute measure.
But this, this gets us pretty close. And you can tell by removing the ceremony. And the ceremony still exists. It just exists in your .proto object rather than being in what's sent over the wire.
Correct. And that brings a couple of nuances. The first one is the good or bad of having more ceremony with the message is that messages are usually understandable on their own. And by that, I mean that let's say that somebody decided to change the XML message, add a new field, remove a field, or change the name of a field, right? When you sort of like read that and try to deserialize it, you may get errors because it doesn't convert exactly to what you have, but you can essentially introspect the message and figure out what happened. Like, oh, somebody lowercase and uppercase field, or move things around.
Right. And that's super popular with JSON, right? The idea of just being able to add fields, where you don't have a schema to validate against. XML could still throw, curveballs at you if you validate it against a schema. But with JSON, if you're not using a schema for that, you can have this concept of destructive and non-destructive changes. So adding fields is typically a non-destructive change, because if your object does not have that field, you can choose not to parse it because it has a name and it has a hierarchy to it. If you remove a field, that's a little different, right? That is a destructive change. So suddenly data that was expected to be there is not there. And a lot of times that is when you still get errors. But what you're going to is, if I'm defining the contract up front, pretty much anything becomes breaking.
It's yes and no. Like the Google people were smart enough to build certain sort of like features on the proto definition to make it sort of like
expandable or
backwards and forwards compatible.
Okay, great.
But the interesting part is that the one thing that you won't be able to do is that if you don't have that initial contract, it will be very hard to understand what this binary payload was. Because like if I have because it's not self-descriptive, right? Usually by default in Protobufs, it does not write out what each field is. It just expects you to already know what each field is
based on position in the message.
Based on positions, and that is interesting because that is essentially the sort of like the linchpin of how to evolve a Protobuf message. One of the things that you notice in the definition is, like, for example, let's take message order proto. The way that you write message tells Protobufs the message order proto, the name of the message, open brackets, and then you write in what you want that message to have. In this particular case, I put in customer proto, customer, because it's essentially referring to another customer, to another proto that I define later. And I'm going to call it customer. But the one thing that, if you notice that what I do is that I put an equals 1. And if you look at the next field, it says, item proto items, it says equals 2. And what that is essentially telling you the absolute must-have order of how this is being serialized on the wire. So the idea is that as long as you do not reuse these indexes, the deserialization of protos will understand how to discard things and how to deserialize the ones that you actually send. So the way this works is, like, if I wanted to add, let's say, for example, a string or a Boolean, right? Has paid, right? To say that an order has been paid, right? The easy way for me to do that is by adding it as the next field in the order proto by giving it a new index. And the cool part is that for systems that are using the old version of the proto, they will get, customer, they will get the items. They will not be able to understand what has paid is, but they will just silently ignore it because really it was not part of the objects that you were working with. So the Protobuf protocol is very sort of like forwards compatible in that sense that if it doesn't understand what field are you sending, it's just going to silently ignore it, But again, the linchpin of this is because it knows that you are sending on field 1, you're sending the customer, and it knows that in field 2, you're sending the items.
Yep, these have to be immutable. So
essentially, yes.
So my statement on contracts and destructive changes versus non-destructive changes, the additions are still non-destructive in this case. But if I remove or if I change the name of a field in position, we're going to break.
It's interesting. So
but not maybe the name, maybe the type, or how much fun can I have with this?
Yes. So it's interesting because the binary protocol does not write out the names.
Okay.
The only thing it says is like index 1 is another message. And, and then it says like, oh, okay. Then you start reading that message and it says like, oh, the message, index 1 of that first message is going to be a string. So, in this particular case, for example, customer proto customer, right? That's part of the order proto. So when it's writing this out, it's going to say like, oh, I'm going to send you a new message, or the index 1 is going to be a new message. And then on the new message, then the first thing is going to say index 1 is going to be a string. So in that way, there is what is called binary compatible changes. If I decided to rename this to customer, let's say the, customer user proto, right? Because for whatever reason, I need to use customer for another one. So I can, if I rename this, we still keep the same binary compatibility, meaning like a proto that was generated on a different contract or, on a previous contract, it still works because the binary generated by it is still the same. If I change this to, first name, let's say that we just capture the first name, then same deal. It will be like, okay, that's binary compatible. We can still talk to people that had the previous one. Now, the interesting part is, for example, if I want to add a last name, and this is kind of like a stickler question, because for some people this will be like murderous intent. The way to do it is you have to.
No, it's so far away.
Yes. It's the cardinal rule where you cannot actually reorder. Yes. So and they are, and so you have to be comfortable with the idea of these fields to be able to be like that. Now, for example, going back to the customer user, right? Like, let's say that you have a name field and you want to split it up. You want to have a first and last name, right? The way to do it, if you're sort of like forward evolving, is what you want to do is you want to add first name, last name, and then you want to declare this one as deprecated. So the idea is that for old systems, they don't know first name and last name because they don't have it on their generated code. They will still just have name. For new systems, the idea is that Protobufs gives you a path for upgrading. So what will happen is like, you almost detect like, oh, if there's a name present, then that means that we don't have first name and last name. We just have name. We have to deal with that. Maybe you do some logic, or you just shove it into first name and that's all what you do. Or maybe you try to figure out if the last name is part of some key set that you have. But the idea is that when you do it this way, first you put it as deprecated and then you remove it. The protos have sort of like a way to forward evolve. You add the new fields, you deprecate the old fields, and then at some point in time, you will remove this field. And what was going to happen is that then people that receive the very old protos will just completely ignore the name field, and you will not have access to it anymore.
Okay, so I don't even have to start at 1, is what you're saying.
Correct. Yes. Actually, there's a way for actually you to specify of the indexes that you sort of like, because one of the things that could happen is that if somebody sees this, they're like, oh, nobody used 1 before. So let me add, sort of like string, Boolean, opt-in, right? And they might say like, oh, maybe I should use 1. Because they never thought that if it was removed, it was for a reason. So there's a way to actually say, to essentially say that reserved. So essentially say, don't use this anymore. And then the way to do that is you just write down reserved, 1. And that usually should give you enough of a hint that, look, we've removed this on purpose. Do not use it. There might be an old system that's still using it, but it's not going to be a Boolean. It's probably going to be a string. So, don't mess with it.
Got it. But that at least means, it reserves that position, and it no longer generates that method. So if I'm going ahead and I'm typing my code and I'm using autocomplete, I'm never going to see a set name anymore because it's no longer in the newer version of the contract. Just like while you're saying, hey, I can change the name over the network, everything's going to work fine. Just all my compiled code will break. So I will have to go back in when I generate and rewrite my handwritten stuff so that it matches the new setter fields.
Yes. So that is one of the things, right? Like, and Google sort of did it that way where essentially it's up to you, right? Like if you version these things, right? Like major, minor, patch, however you do, which, semantic versioning is good. It works. The idea will be that if you're adding things, that could be a minor or a patch. If you're deprecating things, that might be a minor tending to major. But if you rename things, if you add a new library, the generated code will be different.
Yeah,
and that will create sort of like different. If you have old code base that was referring to the old methods or the old names, they will break. So
you will have to rewrite.
Yeah. So that you have to add a major, right? So the fun part is as we go through this, right? Like one of the magic sauces that I'm using is, we're using Gradle for this. Let me just show you this real quick, right? So in the build Gradle, what we have is we have this sort of like we have sort of like come Google Protobuf, right? There is a plugin for it. And what the plugin does is the one that you essentially pointed out to, like, oh, look, I'm putting all my Protobuf my proto files here. Generate me the Java code for me, right? Mm-hmm. So you apply the plugin. We create a source set that says, like, sources proto. This is where I put all my Protobuf stuff. In this particular case, if you can see source, main, proto, data model, proto is there, and then essentially after that, becomes very easy, right? Like Proto-C, this is essentially the compiler, they call them compilers, the compiler that I want to use for generating my Protobufs, right? And in this particular case, come Google Protobufs, Proto-C 3.0. Version 3 of the Protobuf is being used for like 5 or 7 years now, something like that. So it has really not changed. If anything, the only thing that changes, like sometimes they give you more helper methods. Sometimes they become more efficient on the code generated. But in terms of the binary format and all that, they decided never to touch that again. That's a major version revision, right? You tell it where you wanted it to be generated, and then that's really it. So then if you happen to go to, let's see, to Gradle, here, I can just say build, and as part of the build, it will sort of like,
it's broken. Did you change something?
Yeah, I was changing stuff.
You're hacking.
Yeah, hold on. Let's see. Where is it? Pro example. Where is my pro example?
This is the beauty of having a compiled language, though. You knew, you didn't have to guess that you changed something. It just blew up in your face.
Yes, it did.
Maybe it's easier to change it back. Oh, you're going to fix it.
Yeah. Ooh, I wonder.
It's that one because you called it like user.
Oh,
user
that's right. Yeah, let's just fix the data model. Yeah. There it is. Yeah.
There you
see?
Go.
So that was breaking changes.
Breaking. Well, only in your code though. Over the network, that would still work, right?
Yeah.
Because we didn't modify the. We only did additions to the field. So I mean that's super important. And now with Protobufs, and maybe you're getting to this at some point. What's the typical way of sending it over the network? Is there a preferred way of integrating this? Because this is really just the data format, right? So I'm taking objects, I'm turning them into bytes, and now I still have to send them to somebody.
Yes. So one of the things that Protobufs does, and I think that we're just gonna touch on it real quick, because if not, it'll take like hours to cover it. But and I know you actually have that on the Thrift side too. So maybe we should do it just.
Oh, it's built in on the Thrift side. I was just curious. So I wasn't looking for you to go into the particular method. I was just wondering, is there kind of preferred way that most people do Protobufs over the network? Is it a TCP? Is it gRPC? What do you usually pair it up with? And maybe I just, you
spill the beans. No, so the fun part is that Google has something called gRPC, and if you don't know what RPC is, you are both lucky and unlucky. RPC means remote procedure call, and remote procedure calls was it goes all the way back to I guess Windows and Linux, when you're trying to essentially call a method on another program that was running somewhere else, right? And that's where the RPC comes from. But Google has this way of saying, like, that sort of like framework where if you're already using Protobufs, you can declare method calls as part of the Protobuf definitions, and that's using gRPC. And when you do that, then it will also generate, essentially, if you will have the server, it will generate sort of like the server code where you already will have the method call name with the proto ready in there as a proto request and a proto response to return. And on the client side, it will generate the other side and will allow you to essentially plug in and really just write the framework. The reason why I don't cover it that much here is because it's a lot, but the idea is that gRPC will take care of doing the sort of like the network stack as well. So essentially, you just pointed out to like, oh, that particular service endpoint there is or this particular exposed endpoint have a gRPC server. We can actually do gRPC clients of this type, right? So so yeah, in terms of like how would you use it if you just wanted to send it on the wire or on the files, like the fun part is that the Protobufs will just give you a byte array, and then you can use it however you want. For example, you can do application X Protobuf in a lot of the modern web servers will accept that as a header. And there are encoders and decoders that are set up for that. So essentially, what that means is that the body payload will be essentially your byte array, and if you essentially request or if you're essentially doing auto binding on Spring, for example, to Protobuf requests and Protobuf responses, then Spring will know how to decode and encode these for consumption in both in your code and sending it back to whoever was the provider. And the truth is for Jetty, for if you're using Scalatra, all of them will have a flavor of application X Protobuf encoders and decoders for you to work with.
All right.
So let me see if I can get this one running. Let's see. Okay. Let me do clean too.
Yep, with all that generated code. Oh, now there's customer still a customer user proto is not defined. You changed it somewhere. You're going to do death by 1,000 cuts here, aren't you, Freddie?
Worse.
I think you should just change the data model back. Oh, you did? Okay.
No, wait. I did.
Oh, but you still have it at the top.
Oh, there it is. All right. Let's see.
I mean, the other interesting thing is it looks like, as far as Java packages, that's also defined within the proto file. So you know which package it's going into. So if you just want to create like a library file to be shared amongst implementations, you can, I mean, really, almost all you really need is that proto file and your Gradle.
Yeah. So that's the fun part. Like in a lot of projects, what we do is we have just one project that contains the proto files and generates a sort of like a Java artifact, and then we publish that artifact, and then we just include that artifact in our projects. That way, we can say like, oh, I'm using version 1.5, or somebody has to make a breaking change. They'll say, oh, I upgraded it to 2.0. So when you're ready, just update your library. You'll see
version. Yeah, no, that's great.
That's great. And if you can see here, then it actually, it actually generated compiled Java. One of the things that it will do is, in this particular case, it generated the sources, and here we have it, the data model, right? And then the data model is essentially, if you see, is really the same package name. You can always change that, and generated just like that. So by running the Gradle target, it'll be part of your project. Then you can just refer it to as we did here. As a fine bonus, the last thing I was gonna do is just because sometimes you do want to see what's going on. The products will have the ability for you to actually transform it to JSON. So one of the things that it will have is like, for example, it's called a JSON format. That's part of the Protobuf library. It has a printer, and then you can sort of print whatever message you have. Let's see. And in this particular case, you can see, essentially my Protobuf, in JSON format, right? And that allows you to sort of introspect what's going on. I know that it took more time than I thought it was going to be, but I think in closing, it's a very good, sensible. Like, if you don't have a way to do this right now, or you're thinking about, I need to transmit data and information across the wire or persist it somewhere, having Protobufs is a very good choice. Now, the last thing I was going to do is run this test here, which is essentially assuming that you have gzip compression.
So how small can it really get?
Yes. So a gzip XML gets to 227 bytes. Not a lot of improvement from the 320 that it was, right? gzip proto is 89 bytes, which actually I think is a tiny little bit bigger than what it was. And the reason why is because in this particular case, the Protobuf was already efficient on the way that it was written on the wire. So there was not a lot for gzip to do, but again, we're talking about very small payloads, right? Like, the bigger the payload, the more chances of having sort of like compression gains, right? And if you're zipping the proto JSON, meaning like Protobuf as JSON, you get 163 bytes. So again, winner by all measures. The
raw Protobuf. Yep.
Yes.
Very cool. All right. Well, actually, so this is going to work out really well, Freddie. So I'm going to share my screen now.
Yes. I get to drink beer now.
You get to drink beer, and I get to go through things. And the way you covered it, focusing on the data format quite a bit, is perfect, because I'm not going to be focusing on the data format very much at all. Instead, I'm going to be focusing on some of the things around the Apache Thrift framework. So Thrift, the Thrift was created at Facebook. So we have, and it was open source through the Apache Software Foundation. So it's near and dear to my heart, being an Apache project. It has been around for a very long time, based on a paper in 2007. And the idea behind Thrift is a little bit more expansive than Protobufs, because with Thrift, you have a full-featured RPC framework. So we keep throwing around this term RCP, remote procedure call. Now, what Freddie was talking about is basically the data format that's sent over the wire when you're making the procedure call. But the full stack on RPC also includes hooks and contracts for calling the methods. So often what the goal is of doing an RPC call is it looks like you're just calling a regular Java function within your code. But the reality is, under the covers, it's something going over the network, it's writing to a file, it's doing something completely different to communicate with another program. And as Freddie mentioned, maybe in another language, maybe, in another country, just a lot of different formats that abstracts the remote part away from the developer. So it looks like a local call, performs like a network call, and integrates like a network call. So that's really what we're talking about here. And Thrift, unlike Protobufs, provides a full stack for doing that entire end-to-end interaction. So why don't we find out a little bit more about that? Now, one of the things Freddie mentioned is language compatibility. So you mentioned probably 3 or 4 languages. The Apache Thrift website has an entire matrix of different things that you can do with Thrift. The folks that have been working on this have really expanded it to cover a lot of use cases. So I've got C, C++, ActionStrip, Dart, Go, Erlang. So pretty much you name it, we've got it in Thrift. I don't see COBOL on here, but there is Common Lisp if you really want to pick an older language. So you have a lot of options as far as integrating. Now, what Freddie was talking about with gRPC, sending things over the network, Thrift has a number of different things that it refers to as transports. So transports in Thrift can be over the network, over TCP. It can be over HTTP. It can be over memory buffers. So you can just create byte buffers. And dump stuff in there if you want to do it that way. You can do it over files. So if you're just trying to do interprocess things and you're writing to files, there are ways to write to file formats and then read from those file formats. So a lot of different options, and this matrix basically gives you what the options and which availables are implemented in each language, so that if you're looking to integrate, you can do those sorts of things. So that's very cool. Now, let's talk a little bit about how this works. So rather than starting with the code and the server clients, let's go back to something that should look very familiar after going through the Protobufs talk. Is basically Thrift also has its own file type, which stores the file format. And very much like Protobufs, you have an order, you have a type, and you have a label. The difference is very much just in the semantics. Struct is what you're using rather than, what was the Protobuf equivalent of the struct?
Yeah, we use
message. Then you'll define and give it a name. But as far as the types, very similar. You've got integers, you've got strings, you've got objects, you've got lists with basically, the Java equivalent of a generic defined in here. So you can say it's a list of items. But you also have these things called services, which is a little bit different than the Protobufs. And these services are used to generate what's known as in Thrift is a service, which are the RPC calls that you can make with these objects or these structures. So here, these are like method calls, right? So I have a type. This is the return type of this method. This is the name of the procedure that I'm calling. And these are the parameters. And I have an order and a type with the parameters as well. So just like in Java, where if I'm not returning anything, I can also define a void, where if something is going to just if it's going to mutate state or something like that, and I don't want to send anything back. So basically I have this order service where I can get an order number and I can put an order number in a service. These orders have an ID. There's a customer that buys it. There's the list of items that they buy. And each of the customer and item structures have some information about that customer or that item that they've purchased. So your typical e-commerce piece. Now, unlike Freddie, I'm a bit of a Maven fan, so my example is going to use very similar concepts, but in Maven. So the Thrift has a Maven plugin that does some of the code generation for you. So within Thrift, I can define the version of Thrift that I'm using. And again, very similar to Protobufs, The version, there doesn't need to be a ton of releases of Thrift because a lot of these, the structures and the basic things that it doesn't really change. Really, it's more about breadth. They're trying to get more, what can I do in more languages so I can talk to more things? I'll have a library dependency, libthrift. Now, I'm not sure. So if I use Protobufs, Freddie, do I need the Protobuf library in the runtime of the application, or does it generate everything I need?
There is a small
runtime library.
Yeah, and there is a way for you to actually do the minimal ones.
Okay.
But you still have, but by and large, there is a library that you do have to include.
Makes sense. And Thrift has that as well. And again, it's probably a little bit fatter than the Protobuf library because it is also doing additional things like the complete RPC. But as far as the generation is concerned, there's this Maven Thrift plugin. There is a kind of platform compatible executable that does the compiling because it is multi-language. I can't just assume everybody has Java. In this case, I actually downloaded this Thrift exe because I'm running on Windows. There's a similar Linux version of this executable. And this is what does the lifting of going from the .thrift file into the Java code. So from here, I define an execution instruction saying that I'm going to generate the Thrift sources on the compile goal. And I'm using the Java generator. So I'm generating all this for Java. I could use Maven to generate for other languages as well. And then I tell it where it's going to put, this is just really for packaging. This is the build helper to make sure that the generated sources end up in the resulting jar. So I run this. We'll do Maven install. It's going to read my .thrift file, and then it's going to generate the sources and then compile those sources into a jar. So now I have my Thrift classes. And if I want to look at them again, they have the same just very, very noisy look that they did in the Protobufs classes, where it's just like, wow, there's a lot going on here. And guess what? I don't need to know it because these are all things that Thrift is doing for me behind the scenes in order to create the data formats that are required for these RPC calls. Now, the other thing that gets generated, unlike Protobufs, is the service class. And the service class, I'm making this hard by splitting the screen. Let's move that over, make that bigger. Here, let me move this because I feel like our heads are getting in the way. So it generates an implementation and an interface class. So the interface has our get input method. So this is basically our contract. And then I still have to build what these things do. So it basically just generates the contract and how Thrift is going to work with these services under the covers. So what I end up having to write, depending on how I'm going to do the data exchange, I'm going to do it over TCP. I'm going to first have to write a server. And here's my Thrift server. That starts my Thrift process and opens a socket on port 9090. So great, we have a server. Thrift is providing the classes for this, just a simple server. I tell it what the transport is. Again, this is the socket that it's opening. This is the processor that is generated for me. But I still have to tell it, well, what do you do when you call these remote procedures, our get and put calls? That's another class that I have to implement that I'm just calling the Thrift order service. So the Thrift order service implements the order service interface. And again, this is the generated class. So in here, I just define a simple hash map to store my order number, and then the put method is putting it on here. So simple Java interface, I implement these services, and this is my remote procedure call. So all my Java code is decoupled away from the generated code. The only thing I'm using here is the interface.
Nice.
So I can start the server in a main method. So I define it and I start it. And then that opens this port to listen for requests coming in over RPC. So let's go ahead and start that now. All right, so my server started. Well, The other piece of this is I need to have a client to talk to this server. So let's open up my order client. So my order client has to have a similar transport on its side to tell it how do I connect to the server. So if I'm going over the network, I need a T-socket on this side where I'm going to have the host name of the server and the port that I'm connecting to. So again, just a simple TCP parameters in order for me to get a connection to it. I need to tell it which protocol to use. So Freddie was showing the binary protocol for the Protobufs. Mm-hmm. Thrift also has a binary protocol. It also has a JSON protocol. There's actually a few different protocols that I can look at within and I think the main ones are both the. Let me just check real quick. Is the JSON based and the binary based. There may be a few other ones. So yes, I got a JSON based class. I'm trying to see if there's anything other than that. Really, those are the two major ones. Is you have the binary and you have JSON. So you can tell it what kind of format to send it to the wire, and that influences what it looks like as it's traveling across the network. Next, I use the order service client. Now, this client also gets generated for me. So I didn't write any of this client code, but I do have to tell it which protocol that I'm using so that the client knows how to generate the object. So when it's marshaling this data towards the network, it knows what format to put it in. So now here, I'm defining just new objects. So this is plain old Java programming. I don't have the nice builder pattern that we had in the Protobufs. So I'm doing just regular get and set methods on these objects. They're not immutable. Maybe that's feedback for the Thrift team. They can probably create generators that create builder patterns, but that's not what they're doing. Again, probably has to do with all the language compatibility. I don't know that every language can do builders in a similar fashion. Creating my items, creating my order, and then here, on my client, I have my interface named put, where I'm sending the order. And then here I retrieve that order back from the server and then print that out. And then I can close the transport. So here, if I run this order client, I can see I called the put method, it worked, and I was able to get it back. Now,
and this is all going over the wire.
And this is all going over the wire. So we can't see it, but we can see it. So I'm going to spin up my Wireshark. I don't know if you saw my little shark fin sitting there. So I do have
real
a little listener here on the network. So we can actually see what's going on here. So I've just set my Wireshark to look at that port 990, and it's all localhost. So I can capture it on my localhost listener here. And if I want to look, and the really nice thing is Wireshark actually has the Thrift protocol. So I actually get some nice details about, oh, here's my put call.
Wow.
So if I want to look at my call put, I can actually see, yes, it is using a binary format. It is sort of structured where you can tell that there's buffer here. So they're actually, for a string, they're setting a certain amount of spaces for that string. So it's probably very similar to the Protobufs, where it's kind of setting things in their place and setting them in order and delimiting them. But we can get a sense of where. So here's my address, here's the phone number, here's the beer I bought. So you can read this, but if I were to put it in JSON, you could probably read it a lot eeasier.
Yeah.
And here on my get call, you don't really see anything, right? Because this is just sending which method. So the RPC knows what it's supposed to send back. So here's the get call, and here's the parameter that you can see being passed. So this is the order number that I'm trying to pull back. I mean, we can see the replies. Here's the reply coming back. Looks very similar to the put call, or the put call that was sent over the network. So it's using the same format. So as expected, you're going to get the same. You can see the method call. So Thrift basically has its own format. It also provides you with methods and APIs in order to do the entire RPC call from end to end. And if I wanted to do this in C, if I wanted to do this in C++, Python, whatever I want, I'm basically moving that .thrift file over. I'm writing the client code if it's the client, or if I'm doing the server in the other language, I'm moving the server and I'm implementing those interfaces. Now, not every language has an interface, so there are slightly different things, but all of this is very well documented in the Thrift source and tutorials. So if I'm trying to learn another language, this is actually kind of a fun way to do it, because if I can write in Java and I can rewrite in C, and I can just kind of see some of the differences in how these languages handle network protocols. So that's really it. And again, I can change the binary protocol to a JSON protocol. We can mess around with that. We can mess around whether we want to change the actual transport to say, hey, write this to a file instead, and have another application read from a file if we're trying to do something interprocess. But there's a lot of different options within the Thrift framework to do RPC the way I want to, depending on, again, what am I doing? Am I writing to a memory buffer? Am I writing to a file? Am I writing over the network? So that's, again, that's pretty much it. These are fairly simple. Both are simple frameworks to get started from. And really, as a developer, it just comes down to, how much do I want to build because of my requirements, or how much do I want the framework to provide for me? Because in a lot of cases, these are solving fairly similar problems, but there are different opinions on how to solve it and how much the framework does for you versus how much we should be doing ourselves, and where I can change things.
That is super interesting. I have an interesting question. Like the order ID, was that a string or an integer?
Yeah, so if we're going to look, that item ID is an integer, but ordered ID is a string.
Okay. So, that makes sense.
If we wanted to look and see the difference on how those looked over the network real quick, let's see. So the item ID, so beer was the item, right? So item name was beer. I actually don't see.
It's just before it.
Yeah, it didn't really get encoded there, did it?
There it is, 000004.
Yeah.
What was the item number that you send?
Let's check. I don't know. We'll have to look in the client code. So did I set that? I wonder. Oh, so item ID is 1. So 004 is that, or is it up here? Oh, it's this. It's probably this one. That could be buffer. I wonder if it's here. So again, you still have this kind of problem where if you're trying to actually read it, it is a binary format, and it's clearly not being decoded perfectly. These are just bytes, and it's kind of
it's just
doing its best over here for what it can read.
Oh, look at it. Yeah, they have the data structure on the middle window. If you go up a little bit.
There you go. Look at that. Yeah, so the length and structure here. So here's string Bob. Yeah, maybe we can find it. Yeah, string field ID 1, integer, 32-bit. Yeah, so it is this one. It's this one. And if you highlight, so yay Wireshark. Cool that you have Thrift,
I know, right?
Thrift debugger built in. So now we're not guessing. Now we actually know where the one is.
Yeah, there it is. There it is. Oh, I guess it ordered it a little bit differently. Or and as you're saying, the padding. There's padding on it.
Yep, there's padding because it's well, how much does it take up? That fits nicely.
UTF-7. Oh, yep. I wonder if they're doing some kind of like...
And you can see, and again, Protobufs is probably doing the same thing when you add that index ID. So there's stop calls here, right? So that's why if you were trying to mess around with the order or anything like that, and I'm trying to read it, I'm reading it on the server side, looking for these stops. So anything that you move around, obviously, can be a breaking change if you're trying to overload a field or you're trying to reuse that one. I only see the stops in the types, really.
I see. Yeah, no, that makes sense. And we probably have the same evolution rules where as long as you don't mess with the actual index numbers.
It's fine. So very cool. Hopefully, this has been kind of a learning experience with Thrift. You can use either of these languages in conjunction with your app. I think it's really a lot of the decision comes down to, how much ownership do you want to have? Do you want to be able to decide More around, hey, what am I going to do with this after I just do the data transform into bytes? Or do I want something just to take care of it for me?
Yeah, right. No, and I agree. I think that is part of it. Like I think Protobufs, and I know that we probably need to do a gRPC session next, just to cover the breadth and depth, because they overlap a lot on that. But Protobufs on its own is just a way to encode and decode, and sometimes you have to work with what you already have, right? Like maybe you already have an endpoint, you're dealing with a payload that you have on a REST endpoint that you just wanted to do it a certain way. Then Protobufs gives you that, just very targeted. Oh, here it is. Here's the byte array for you to do whatever you want with it, right? And like we see I know that they try to minimize the use of buffers. They're actually pretty smart about like even encoding things like integers, because they say they try to do this thing where if they figure that the integer can fit in less bytes, then they will use less bytes to encode it. So I know that they're trying to do this, like make it as byte or as compact as they can.
Yep.
Keeping all the information. So I think that there might be a little bit of a difference where Thrift is more. It concentrates more on your ability to actually just say, look, most people when they're encoding and decoding, they're just trying to call another service. Right. So they're remotely calling a method.
Give me the method. Give me the method. I'm going to call it, and we're going to pretend like it's not going over the network.
Which is nice, actually.
Yeah, no, I mean, it has its own convenience. And you can see, I mean, again, the lengths are not large. Some of these, I'm not sure how this object compares to some of the ones that you had to say whether Thrift or Protobufs is more compact. My gut tells me Protobufs is probably a little bit more compact.
I think it might.
This is a smaller object, and I think these sizes are a little bit bigger than the ones you are working with. But again, decide on what's important, and what your team, what you want to build, what you want to take from something else, the framework, and this. Hopefully, this will help you make that decision.
Yeah, isn't the Java ecosystem so beautiful?
Oh, it's so awesome, right?
Yeah, like we have so much. We're spoiled by choice. No, definitely, and I love that they actually have async methods as part of the. Because what that allows me to do is been working a lot on reactive or reactor service, and async methods are a must. So
they are pretty high performance. I mean, again, a lot of these were built out for high performance remote procedure calls. So I mean, you can scale these things up quite a bit.
Yeah, no. So I guess that and like you said, that's what it is. Choose your framework. There's many to do. I know that we'll do a gRPC later, just to compare apples to apples, right? But yeah, wow, Thrift is so much fun. Now I wonder, where can I use it on what we're working on?
Well, if you've got Go, actually, I'm sure there's Protobufs for Go. It's Google.
Yeah, that one still have, yes.
But just to get back to the slide, if you're going to integrate to Lisp, this is your option.
That is, I can't believe somebody actually took this spot. Yeah. Well, I think that's all what we have for today, right?
I think so. But yeah, another good one. I hope the folks listening or watching learned something here today and something that they can apply. It doesn't all have to be JSON over HTTP.
Yes. I mean, again, do remember that there is, we are paying by the cycle now, right? We're renting out Big Iron. You're paying by a particular CPU core that you're using. Binary is way more efficient than string, just because just there's less things to do. So these protocols are definitely a step above just sending stuff on JSON and XML. And remember, JSON is essentially JavaScript friendly, where it does map to sort of the JavaScript memory model representation that they have. But if you're not dealing with JavaScript, meaning like it's a server to server communication, and these servers are not running JavaScript, then there is actually an incentive of moving away from JSON and trying to use something that is more compact or more performant. And it does make a difference. If it's one message that we're looking at, it doesn't really matter. If it's 100 messages, 1,000 messages, 100,000 of messages, big difference. So make sure that you encode it. That'll be your next project for the holidays that are coming up, and make sure that you've reduced your cloud profile for 25%. They have money for you for your next bonus.
Absolutely.
Right? All right. Well, that's it. Cheers.
All right. Cheers, everybody. Till next time.
Yep. Happy programming, everyone. All right.
And recording.